So next several assignments are going to be continuing through that game that you were working with the videos, and I'll actually put up the next several ones in case you want to just keep trucking. In class, I'm going to start talking about another concept that's not covered in the videos called procedurally generated worlds. So we'll talk about what that means here in a few minutes and that kind of stuff. That way you kind of have two different cadences. You're getting more of a theory thing in here. You're getting more of a practice thing out there. Sound good? But like I said, I'll put the next several assignments up in case you want to get ahead. If you're like in the zone and want to spend 2 hours on the videos and get 3 assignments in, that's fine. Let me get the slides open here. And we will hope that iCloud is working again. Oh, and they did announce that iCloud did have an outage last week, so it was not just me. All right. So the exams in here had a huge range. So they ranged, there was 100%, and I think the low was 20-some%. I guess technically there were some zeros because some people just decided it wasn't worth taking, but whatever. Okay, so let's go over this guy. All right, what's the purpose of a game engine and what did game programmers do before we had them? You probably needed to mention something about physics in there, that the game engine is designed to pre-write a bunch of the components that are common to most games. For example, physics, you might have talked about movement, you might have talked about collisions, things that are going to be common across a lot of different games are built into a game engine so that you can focus on the game logic, the contents of your game, rather than all this other stuff that's not going to necessarily change between two games. So what did we do before we had those things? Well, as a game programmer, you would have had to write those components yourself, or more probably what you see from some of these older games, they're a lot simpler. You probably would have had a much simpler game because they either A, didn't want to write all the extra stuff, and maybe more probably B, they didn't have the horsepower to do a whole bunch of things at once. We didn't have the computational power to handle 1,000 instantaneous collisions plus physics plus all this other stuff. Back in the old Nintendo 8-bit days or the Atari days, nobody was talking about the frame rate of your video game, right? It kind of didn't matter when you were playing, the original Mario Brothers, not Super Mario Brothers, but the original Mario Brothers on an Atari 2600 on a black and white TV. It didn't really matter. My brother set some record on that game, and I remember there was like a video game magazine that you could send your things. It was like an impressive record for like kids at the time, right? I don't think it was some sort of world crazy whatever, but he, as far as that magazine was concerned, it was like the farthest somebody had gotten or something like that. So I remember we took Polaroid pictures of the TV screen, like his score and stuff like that. That's what you would send in with like your little card claiming what your score was. Now you'd have to take a streaming video. I see these guys that do like the Super Mario Brothers speed runs. Have you seen those? Those are pretty interesting. All right, so in any case, something along those lines for number one. Number two, what's the minimum component requirements for something to be considered a game object? Explain the details of any required component. Okay, well, the bare minimum is a transform. And what is a transform? It is a collection of 3 vector 3s, one for position, one for rotation, one for scale, where a vector 3 is a struct that holds 3 individual variables, an x, y, and a z, which are all floats. Okay, so something that gets at least 2/3 of the way there with that level of detail or something like that. Some people put in as long as you had the transform, that was the most important part. I think a couple of people mentioned something about that. Most game objects, when you first drop them in, I think a game object, when you first drop it in, it also comes with does it come with a mesh collider, or does that come with a rigid body? I don't know. If you put something like that in, I didn't take points off as long as the other stuff was fine, whatever they said. All right, questions on that one? Okay. 3, what's the purpose of a rigid body? And what are the purpose of the constraints as it relates to the rigid bodies? Okay, so rigid bodies is our way of having gravity, right? So it also supports collision, so you could have said something along those lines, but the gravity is the big thing. So a rigid body makes something solid, gives it a mass, and allows gravity to impact it. Then when it, the connection to where it supports collisions is that something that is heavier, when it collides with something else, it's going to have a different impact on how things bounce apart and that kind of stuff. So something along those lines with gravity is probably the thing you needed to say there. Now the constraints with rigid bodies, these have to do with locking in the position as well as the rotation on the axes. So we did this with our golem, where he was kind of tilting forward, tilting back, tilting side to side, stuff like that. Or if we wanted to keep him from popping up in the air, we can constrain him on Y. So when he got hit, he wouldn't jump up in the air when he bounced off stuff. Similarly, we can constrain his rotation on the various axes to keep him from falling over. So how did I ask it? What's the purpose as they relate to rigid bodies? To make a rigid body act the way you wanted it to act, rather than allow gravity to take over some of your axes, whether it's rotation or whether it's position. Make some sense? All right, so those are constraints. 4, what is MVC and how is it implemented in Unity? Explain both sides of the implementation in Unity. So MVC is the model view controller. What does that mean? It means it's a good idea to separate your logic from your interface. Design your interface in one place, put your logic in another place, and then we have to have some way of getting those guys to connect. And I wanted you to explain how that connection happens from both sides. So, for example, if I want to expose a variable to the design side, so if I want the Unity editor to have access to something that we've written in code, I make that guy a public field, right? You put public in front of it in your code, and then all of a sudden that dude pops up in the script over in the Unity editor. All right, so that's one direction. How do you share something from code into the editor? Other direction, how do you get something from the editor in code? You do that through the get component function that allows you to grab the entity, the game object that owns a script by saying this dot in your script, and then you can ask that guy for one of his components by saying dot get component. And you can tell it the type of component you want, and then you extract that. Now you can manipulate things that were dropped into the designer through code. Make sense? Okay, so that's the two sides there of MVC. 5, what's the difference between update and fixed update? So update runs every single frame. Okay, so regardless of how fast your computer is, it's going to run every single time your graphics card is able to display a frame. So this was going to happen at a different cadence depending on the quality of your gaming machine, for example, or quality of your GPU, for example. Fixed update attempts to have a level playing field. So it's going to run at 60 frames per second. It's going to execute that code 60 times every second, regardless of how good your graphics card is. I suppose you could say something along the lines of, if you had a really crappy graphics card that couldn't maintain 60 frames a second, now you're operating at a disadvantage. right? Because it's not even going to be able to do 60 frames a second, but it's limiting itself to 60 frames per second. So what's the advantage and disadvantage of fixed update? Well, advantage of fixed update is it creates more of a level playing field across the board. Everybody, regardless of the quality of your machines, as long as your graphics card can maintain 60 frames per second. So whether you're at 60 or whether you're at 200, you're all operating at an equal playing field for at least the logic you've put inside a fixed update. So that's the advantage of something like that. Another advantage you might say is performance. Regardless of the end user experience itself, if you have some logic that's literally occurring every single frame, that doesn't really have to happen every single frame. Moving it into fixed update still has it happen automatically on a consistent cadence, but reduces the amount of times you actually have to call that logic, which then makes your game less resource intensive, higher performance, whatever, things like that. What's the flip side of that? Disadvantages of fixed update. So one disadvantage of fixed update is depending on what logic you're putting in there, you might miss out. If something happens between the once every 60th of a second period, you might miss out on a collision or something like that if you're doing detection in there related to that. I think we talked about in class that if you wanted to do movement stuff, you probably could put that in fixed update, because chances are a human being is not going to be able to do a manipulative button press or something like that faster than 60 times in a second. So we're probably going to capture that button press or something like that. So at that point, that's more getting into the category of benefits, where we're having an equal playing field for all the people playing the game. But losses is when you have things that are happening in the game automatically or automagically, and they might occur in between those 60 frames per second. So you might miss an opportunity to apply logic to something. So that's where you need to make that decision of, does whatever I'm doing, whatever I'm checking, does it belong in the fastest possible situation, or is it better to put it over here and fix update? All right, questions about that one? So something in the ballpark of some of the pieces I just said. 6, what is a collider and why do we need them? Well, so a collider is a component that attaches to a game object that allows a game object to interact with other game objects that also have colliders attached to them. Okay, so colliders interact with other colliders. It allows us to have things that bump into each other. And whether we want to have physics directly involved in that, or we want to programmatically handle when a collision occurs, we get those opportunities. But the purpose of a collider is so that we can detect when things bump into each other. Let's see. What are 3 examples of collider variants in Unity? So we have a box collider, we have a sphere collider, we have a capsule collider, you have a mesh collider. So that's 4. So those are different collider variants. Do colliders always need a rigid body? Why or why not? No. So colliders collide with other colliders. So a rigid body is not required. A rigid body plays into collisions in the event that you have 2 things colliding with each other and you're allowing the physics engine itself to manage what happens when they collide. At that point in time, the mass associated with a rigid body would play into how hard these guys hit each other and who bounces off of who and stuff like that. Okay, so rigid body not required for collisions to work, but it will give you the advantage if you wanted to have physics-looking stuff. All right, questions on that one? How can you implement your own update method that runs every second? Explain in detail. So we talked about this in class last time with that exact example, right? So this is using a coroutine. All right. So the idea is what is the update method? The update method is something that operates that runs every single frame. Fixed update runs 60 times a second. What I want to do here is I want to make a update-like method, so something that automatically runs at a certain cadence, but I want it to fire every 5 seconds. So a lot slower, but still on a consistent basis. How would we do this? Well, what you would do is right at the beginning of your script, so inside the awake function, you would go ahead and start a coroutine. And what would that coroutine do? It would first wait 5 seconds, do its logic, then call itself. Make sense? And when you call itself, what does it do? Waits 5 seconds, does its logic, calls itself. So you have something that's happening every 5 seconds in perpetuity. All right, so you've built your own update function that runs in its own thread. Okay, and that's what's kind of the important concept of that is it's not a blocking call. So it's running separately, just like update runs separately, just like fixed update runs separately. So the logic that's happening in there isn't blocking or getting in the way of the stuff that's running in update or fixed update. All right. All right, does that make sense? How that one works? So something along the lines of a coroutine. We did have a couple of interesting hack approaches, let's say, like maybe in you might have some sort of counter in update, or maybe the more accurate way of doing this would be something with time delta, where you would keep track of current system time in update, and once that built up to 5 seconds from your original, then you would go ahead and perform your logic and then reset the clock. So you would have update have a piece of logic in it that only actually executed every 5 seconds. Technically, this would work. It doesn't really fulfill the idea of having your own update function, but it would technically allow you to have something that happens only every 5 seconds, but it would be pretty resource intensive. So at that point in time, you're putting a lot of, is it time for this to fire in your update method that's firing every single frame? So every single frame you're checking, is it time for this to happen? 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 And finally it is time. You make it happen, then you reset the time, and then you continue saying, is it time for this to happen? Is it time for this to happen? So on and so forth. All right, make some sense? So not the best solution, but technically a solution to the problem. Let's see, what one are we on? Number 8, what's a blocking call? Well, a blocking call is a call that prevents the code from that's after it from executing until that call completes. So it blocks the stuff below it until that guy has finished. Why do we want to avoid these in update and fixed update? Well, we rely on update and fixed update to run very consistently, and a lot of the times we're asking questions like, did something collide? A lot of times it's movement based. Are they pressing the left arrow? Are they pressing the right arrow? Or do they press the space bar for jump? Whatever it is. We want these things to happen, and we want it to be free-flowing logic on a once per frame basis. So having any sort of hiccup, any sort of blocking call, anything that keeps us from moving forward at a fluid rate is going to be kind of bad news in update and fixed update. So if we have something that might take any more time than an if statement, technically you can say an if statement blocks, right? At the most basic level, let's say it blocks because we have to wait for the Boolean expression to resolve before it can move forward. Well, we might say under the general circumstances, an if statement's Boolean expression resolves instantaneously, right? Or very close to instantaneously. But the reality is we're at the mercy of what that Boolean expression is. What's a Boolean expression? Yeah, any expression that boils down to a single value of true or false. So that could be us calling a function that we wrote that returns a Boolean, and inside that function we do all sorts of crazy stuff, that might take an hour or something like that. Maybe we're, calculating the, pi to the 4,000th or 4 millionth decimal place or something like that. And it's just going to return true when it's done, something like that. So that's going to be a little bit more than a, than a blink. All right. So blocking calls prevent other code from continuing on until they're finished. The generic definition of a blocking call, and we don't want them in update or fixed update because we're very reliant on these things happening extremely often. So nothing that's going to slow things down should be in there. In fact, we really, I just mentioned the idea of an if statement. We probably want to limit the number of questions we're asking inside of update and fixed update. A lot of times we can't make a decision unless we have a question, right? Did they press spacebar? If so, make them jump. That's reasonable to have in there. But if you start having thousands and thousands and thousands of questions inside of update or fixed update, those start adding up to measurable time. Okay, so typically a question is a little slowdown. Some of them are going to be necessary, but you also don't want to have a million different if statements inside of your update because that's going to slow things down as well. So decide what absolutely has to happen inside of update, and then move the other stuff maybe into a coroutine if it's questions that you want to ask as often as possible. Because you can do that in a coroutine as well, right? I mean, a coroutine is running on its own thing, and you might say, look, I want this to run every 5 seconds. But if your logic takes 3 seconds and then it sleeps for 5 seconds, it's actually only running every 8 seconds, right? But at least you're not slowing down your update or your fixed update method with the time associated with your logic. Will you hit the light switch in the hall there real quick? Thanks. Yeah. So in any case, that's the scoop with that guy. That makes some sense. All right. Thanks. Which one am I on? All right, we're on 9 now, right? What are triggers as they relate to colliders? Why do we need them? All right. So if you remember, on a collider, we have a little box that says is trigger, right? A little box that says is trigger. And if we hit that box, first thing that happens is we've turned off physics. So automatic physics no longer occurs. We haven't turned off gravity. We've just turned off automatic physics. So now when you have a collider that bumps into another collider, if at least one of them is a trigger, that particular guy is not going to have physics impact him. He's not going to go bouncing off. He's not going to do any of this other stuff. The purpose of it is for us to say, look, I want to know when these things hit each other, but I don't want them bouncing off each other or something like that. I'm going to handle this programmatically. So is trigger allows us to turn off physics and programmatically handle what happens when these guys collide. That makes sense? Okay. Now we also have let's say I want physics to happen, but I also want to programmatically deal with a collision. How would we do that? Is there a way for me to programmatically handle a collision and still have physics occur? So we looked at both of these functions. The trigger one was on trigger enter, right, associated with a collider. And if we have a whole bunch of colliders that are triggers, we'd have to start playing the tag game. Is the collider involved in this dude a player, or something like that? But if we want to programmatically handle a collision that isn't a trigger and has physics turned on, we would use the function on collision enter. Okay, that guy gets called automatically anyways, right? On collision enter gets called every single time there's a collision associated with this game object, but it's the alternative to the on trigger enter. So this is only collisions that are not triggers that would call that guy. And now we're saying, let physics occur. These guys are bouncing off each other, whatever, but I'm also going to deal with it programmatically. Maybe it's to update the score. Maybe it's to make that guy die in 3 seconds, something like that. Whatever it is, we kind of did that with our golem, right? We looked at a couple different approaches with our golem. One being a trigger, which allowed the pumpkin to fly right through him, right? But still, we detected that, hey, he's a thing, and this collision occurred, so we're going to make this guy invincible for a period of time. The other way is if we leave the is trigger off, the pumpkin hits him, we see the pumpkin kind of bounce off or whatever. It's a physical interaction, but then we could also we made him invincible for 3 seconds or whatever it was, so that he can kind of reposition himself and not be in a constant state of getting hit by pumpkins. All right, questions on that one? The idea of triggers. All right. Why we might use one. You could use the example with the golem, where we want the golem to know when something hit him, but we didn't necessarily want pumpkins, bouncing back into our field of play or something like that, right? Because then you have pumpkins interacting with other pumpkins and that kind of stuff. You might also, even in that example, you might just say a pumpkin is a trigger so other pumpkins don't bump into each other. Or if they do, they're not having a physical impact, although that probably makes our game a little more interesting when you have potentially a pumpkin can bounce off another pumpkin and change angle, and you have to dodge it more interesting or something like that, interestingly. All right, last one. What is the observer design pattern and how do we implement it in Unity? Okay, so the observer design pattern says it's a good idea to be productive while we wait for some event to occur. All right, so this is us saying we're going to let our game keep running, and as soon as something actually happens, are we going to react to it? Well, the simplest version of this is inside of update. You throw an if statement that says, only if this thing happens am I going to do something about it. Now, the reality is that's not really an implementation of the observer pattern, because instead of you being notified when something happens, you are now constantly checking, did this occur, did this occur, did this occur, did this occur? And in real life, if we're trying to be productive here, but we're constantly glancing up, maybe we're waiting for somebody to come through that door. If we're constantly glancing up, are we being as productive as we could be? Because we're constantly checking, right? So the observer design pattern says you should be productive, and when somebody comes to that door, we're going to let you know. So we just gave an example of it with like the on trigger enter. Okay. We're just going to go about our business, and as soon as a trigger is, a collision occurs, whether it's a trigger or a normal collision on collision enter, it's going to notify us that something has occurred, right? And only then do we have to deal with, some things have bumped into each other. Do I care about what bumped into each other? If so, what do I do about it? But they're going to let us know instead of us constantly checking. Okay, kind of get the difference there? Because we could put inside of an update method the constant cadence of saying, did these two things collide? Did these two things collide? Did these two things collide? Maybe we even ask the question about whether they collided geometrically by saying, if I know the size of these guys, is their center point in a position such that they're currently overlapping, right? Where we can say that they are physically too close to each other to not be hitting each other. So we could be asking that question every single time through update. Are these guys positioned closely to each other where they're probably touching? If so, I'm going to do something about it. But now we're asking that extra question every single time through there. There is also an implementation of the observer design pattern, depending on how far you've gone into the videos, called send message. That allows one object to send a message to another object. So that allows you to do your own raising of events. Okay, so maybe inside of on trigger enter, for example, something occurs. You can then say, I'm going to send a message to all other game objects on, so you might have 10 scripts. Let's say 10 scripts on a particular game object. You can have one of the scripts on a certain event send a message, and all of his other scripts, if they have a function that matches the message you sent, it'll call that function on those guys. We'll see an example of that at some point, but that's your way of raising your own flags. Okay, but up to this point, our example of the observer design pattern is, us being notified when something has occurred. All right, questions on that one? All right, so that is the exam. Remember that the final exam, if you do better on it, can replace whatever you got on this guy. So if you're not happy with the grade you got on this guy, the final exam can help you. Remember that the extra credit opportunities we have during the semester won't help you on the exams, but it'll help you throw out a crappy assignment or a crappy quiz or something like that. So between the two of those, you have plenty of opportunities to boost your grade in the event of a one-day hiccup. All right, so we're good with all of that. Make sense? All right. So let's continue on then. Later on today, I will put up the next several assignments related to the videos, and I will go back to the videos at some point, but there are concepts that aren't covered in the videos that I want to make sure get covered. So we're going to talk about that in class, and then we might have an assignment off from the videos so that you can do something related to this where you might have two projects going simultaneously. All right. Now, how many of you have ever heard of a game that says it has procedurally generated stuff? Okay, so procedurally generated, something like that. The game that most recently comes to mind is No Man's Sky. Is that what you were thinking of? All right. So for starters, what does procedurally generated mean? Kind of a fancy way of saying what? Okay. There's likely a randomness associated with it, but not necessarily.
It's like it's not, the world's not created by like graphic designers. No, it's just created by using algorithms and different functions.
Yeah. So really, from our perspective, it almost falls into that MVC type category. Instead of us dragging crap all over our designer to build our world or build some aspect of our world, we can write code that generates the world or some aspect of the world. You know, No Man's Sky, the idea was that, you know, you have this giant universe or whatever, and it was procedurally generated. So, you know, the idea is there was so many planets that you may never run into another person or something like that. And, you know, the time it would take to have a designer go through and build all those scenes would be difficult, very time consuming. Now, the reality is that with that, you probably start with some sort of starting point, right? Like here's our generic, if we're just talking about No Man's Sky for a second, here's what a generic world looks like. Now we're going to start, you know, plugging in the variables about this guy, maybe, you know, the color of the clouds, the number of moons, you know, stuff like that makes one world at least visually unique to another world. So when we have a starting pod for something, what do we call that in Unity when we have kind of a starting point? Prefab. Yep. So this is going to leverage prefabs. The idea of a procedurally generated whatever says that we are going to programmatically, and that's a fancy phrase for write code that accomplishes something. So we're going to programmatically generate aspects of the game. All right, so this can be all sorts of different things. Something we're going to be looking at in here, we're going to start off with kind of a basic version of this. But what we're going to be moving towards is how can we procedurally generate the department, the rooms in the department. All right, so we're gonna look at this from the perspective of We're gonna look at this from the perspective of JSON. So how can we describe this environment through a data representation language like JSON, and then read that JSON and actually go and build at least the shell of the department, something like that. Just kind of proving that we can use prefabs to generate different shapes and different hallways and stuff like that, and have these guys linked to each other. So that's ultimately where we're going to go with this, but we're going to start off much simpler than that, not have like these hollow hallways and things like that. All right. So when we talk about procedurally generated things, our most basic prefabs that we have in our that come with Unity are like our cubes and our spheres and these things. These are effectively prefabs, right? All right, so now what we're going to do is I'm going to go ahead and open up Unity here, and I'm going to start a new project on here. All right, and we're going to call this guy procedural generation. Sounds legit enough. And we'll click create project. Well, this is cooking. Any of you follow NBA?
NBA?
Yeah, basketball.
Somewhat.
Did you see Klay Thompson made 14 3-pointers yesterday? And he came out early in the third quarter.
Oh, 14 in the third. By the third?
By early third. Yeah, they smoked the Bulls yesterday, so they didn't. He didn't play most of the second half. It still made 14 3-pointers. It's an NBA record. It's pretty ridiculous, right?
Yeah.
It was raining, and most of it didn't even hit rim or anything. Yeah, the net had scorch marks on it.
Should be a pretty easy one again this year.
I don't know.
4 years in a row.
I don't know about that. I think Western Conference is going to be a rough conference. I think Boston. You could probably put Boston in the Eastern Conference Finals. Although Bucks are good.
Well,
yeah, their Eastern Conference good. Yeah, that's true. So I don't know. Right now, I might pick Bucks over Boston. They're shockingly good. But yeah, I don't see a 7-game series with Golden State going well for Milwaukee. That's probably a true statement. Okay. So ultimately what we want to try to accomplish here is, sometimes when you're dragging stuff into your scenes and stuff, it's almost a little bit difficult sometimes to get things to kind of line up the way you want them to line up and stuff. And now the reality is when you're building like a very detailed forest scene or something like that, where you're going to put a tree here, these aren't really things that can necessarily be initially what I'm going to be looking at here is how do we represent certain patterns through objects and get them positioned on the screen in a certain place. So I'm almost thinking about, let's say that we wanted to have, we're gonna initially build like a tic-tac-toe game, okay, in Unity, but we're gonna have a procedurally generated board. Okay, now, but let's just start off with this concept of go to my scene here. I'm going to go ahead. I'm going to start putting some stuff in here. So I'm going to just create an empty game object to keep track of my board. So we're going to start off by almost building this guy manually. And then we're going to think, how could we have done this procedurally? Okay. So we'll call this guy the board. And then I'm going to go ahead and I'm going to add some cubes to this guy. So we're going to say that each of our little play areas that we could click on or whatever is a cube. All right, so we'll add one cube there. Now what I'm going to do is I'm going to click on the z-axis. I could also do x-axis. One of the axes that allows me to look at this cube head on, not at one of the corners. Okay, so I'm looking at this guy head on. So now what I want to do is I want to get a grid built of these guys. Now we're going to start off by kind of dragging the stuff around. So, I'm going to kind of lift this guy up a little bit. We'll move him over a little bit. I'll go ahead and I'm going to put a new cube in here. Okay, we'll drag him up. Okay, we'll say he's in a pretty good place. We'll put another new cube in here. Okay, I'm actually going to just copy this cube real quick so I have a quick starting point for these guys. All right, I'll drag him up and drag him over. All right, then I'll put another cube in here, drag him over. We might as well just create it this way because it's pasting in like the wrong hierarchy. All right, there's that. I'll do another one. And we'll drag him over. And then just to make things a little quicker here, I'll copy my last three, paste them in, and just drag that straight down, something like that. All right, so I've created kind of a gritty type of thing here. Okay, but these guys are just roughly placed, right? If I go and look above, okay, things look mostly lined up, but we kind of see these guys aren't quite positioned perfectly, although it kind of does actually have an interesting look there. You know, you could probably build something like this that has you think about those space, you know, like all racing or space tunneling type game where you're controlling the thing that's going through like this tunnel, and you kind of want to give this effect that you're kind of going through corridors. If you imagine this being like this infinite hallway here, where as you're flying through, you're going to see these little rivets kind of fly above you. This actually, if you took out this middle column, would kind of look that way, right? Maybe put a couple side ones in there, which just looked like a big tube. So kind of an interesting way of doing it, but you're probably not going to want to place, I don't know, let's just say 5 million cubes by hand. It's probably something you want to generate. Okay, so we're going to look at some ways that we can do this. So switching back here to this view, you know, we could probably get these guys lined up a little bit better. So if I click on this dude, I have a Y of 1.3. I'm going to go ahead and let's just set that to a Y of 1.1. So it's just a little bit above. Now, what I can actually do is I can go ahead and I can select all of these guys, those three, and give them all a Y of 1.1. So they're all positioned at the right place, right? Similarly, I can select these three guys, the next three, and I can make sure they all have a Y of 0. And then I can get the last three and maybe set them at a negative 1.1. All right, so now at least they're equal spaced up and down, right? So now to get them side to side in the right place, you know, if I'm going to say this guy is at a Z of negative 1.27, I'm going to put it at a negative 1.1. All right, and I'm going to go ahead and select the next two of those guys. And we'll put that at a negative 1.1. That has a weird look, doesn't it?
Aren't they like on color for the same spelling?
It's really interesting. So this guy. Oh, well, I see what you're saying. They are all the same right now, right?
Yeah, they're all like inside.
Yeah. But did I change the X? I must have. Okay, so if we drag one of these guys over on the.
Or the Z's there.
Oh, I get it. So I want one of these guys to be negative 1.1. Actually, that doesn't put it in the right place, though. Let's go right above. We'll shift him over on top of this. Although we're kind of moving all of them. I want to move that entire stack over to be placed right. So let's just get these guys separated again so they're positioned-ish better since I messed it up. All right, so now I'll zoom out a little bit. All right, so I want these three guys to be positioned on top of each other. So this guy needs to be at a 0, right? And then this guy needs to be at a 1.1. Yeah, I selected the Well, ultimately, he is going to be at a 1.1. This guy will also be at a 1.1. This guy will be at a 1.1. This guy will be at a negative 1.1. Negative 1.1. Negative 1.1. All right, so we have a pretty reasonable layout now, right? And I look straight down, those guys are seemingly lined up pretty well. Okay, and that's just working with 9 boxes, and we had to do some manipulation. So we can imagine if you're doing a much more complex world, things would start sucking, right? Okay, so how could we programmatically generate this? We're going to have to represent our objects in an interesting way, and we already know how to do that, right? We already know how to instantiate stuff. So I can create a script that instantiates a bunch of boxes, right? How do I do that? In my little world here, if I want to have a script, I'm going to go ahead and just take all these cubes, and I'm going to just make them invisible. I'll remove them from the scene. All right, so I just have my board here. I can add a script to my board, which is an empty game object, and have this guy effectively create my cubes, right? All right, so we'll go ahead and create a script for this guy. I'll create a little scripts folder just so we're consistent. And inside of this folder, I'm going to create a new C# script. And we'll call this guy generate board, something like that. All right, and we'll go ahead and pop this guy open. Whatever. All right, so now we did something similar to this with our golems, right? Or our pumpkins, rather, where we use the pumpkin prefab to generate multiple pumpkins. We put them at different places and things like that. So how do I allow this script to know about a specific prefab? I want to be able to drag a prefab into this script over on the Unity side. So I'm going to make a public, and what kind of object is it going to be? Game object. All right, and we'll just call this guy, we'll call it a cube. All right, so that's going to be a specific cube that we're going to use as our prefab. All right, so now we'll go back over here to Unity. And we see on our, we'll click on our board. We're going to go ahead and add our component to that, generate board. So let's drag that guy over there. And notice he's expecting me to give him a cube. So just for the sake of argument here, I'll go ahead and just create a brand new fresh cube. Okay, and I'm going to name this guy a cube. We're not going to do anything special to him. It's just going to be literally be the primitive type. Just to, again, keep us used to making our organized thing here, I'll create a folder called prefabs, and I will drag a cube into that folder. So now I have a prefab version of a cube. And prefabs can be used to instantiate more cubes, right? Okay, well, instantiate multiple instances of that prefab. All right, so I'm going to go ahead, and this board thing is expecting me to pass it a cube. I'll go ahead, oh, not that guy. I'm going to delete this guy so I don't forget about him. And I will drag my prefab in here. So now my script has access to the A cube prefab that I can use to instantiate more cubes. Make sense? All right. So now what I'm going to do, just as a starting point, inside of start, I want to go ahead and I'm going to instantiate 10 cubes. Let's just say. All right, I'm going to have 10 cubes. And I want these guys to be all in a line. So if we come in here and I put a cube into the scene and I put another cube into the scene, these guys should be roughly, I'm going to go just on the Y here. And I'll drag these guys here. Actually, what I'm going to do to start, I'm going to click on both of these A cubes. And I'm going to click on the little gear here. And I'm going to say reset position. That'll put them at 0, 0. And then what I'll do is I'll just take one of them and I'll drag him over. So we're going to move him on the X. So maybe what we'll do is we'll take jumps of 1.1. So we'll position him and then a multiple of 1.1 over. So I'm going to do something 10 times. I'm going to instantiate 10 cubes. How do I do something 10 times? For loop. All right. So we're going to say for int I is equal to 0, I is less than 10, I plus plus. All right. So we're going to go do something 10 times. Now, what am I going to do each of those 10 times? I'm going to instantiate a cube and then position it on X where I want it to be. Right? Well, let's remind ourselves, how do we instantiate something? So here's our instantiate function, and we can give it the original object. So remember, there's a whole bunch of versions of this. So we have the original object, we have the parent transform, we have a vector3 position, and then a quaternion starting point. So we maybe want to use this guy to make sure he's positioned in the right place. All right, so we're going to say, who's the original object? Where do I want him? And what's his initial rotation? So I'm going to go ahead and create one of these guys. So we're going to have a vector3 cur pos. And we're going to start this guy off as a 0, 0, 0 vector3. We'll just start him at that beginning little point. So this is going to be a new vector3 0, 0, 0. All right. So what are we going to instantiate? We're going to instantiate a cube. Where are we going to instantiate it? We're going to instantiate it at cur pos. And what's the rotation? How do I get a default rotation? When you think about rotations, what's the crazy word that pops into your head? Quaternion. All right, so we have a quaternion dot, what is it? Default? Quaternion dot identity. So that's the 0, 0, 0 rotation. Okay, so this will place a guy at cur pos in my scene over and over and over again, 10 times. All right, so what I'm going to do for a moment here, I'm just going to go ahead and dump all these cubes that we placed in here, just so they're not screwing with our world. Okay, I'll make sure I save my script here. So what does the script do when it starts? It generates 10 cubes and puts them all at 0, 0, 0 with a default rotation. Run my game here. There's my 10 cubes that all got built. Okay, but they're all right on top of each other, right? All right, so we want these guys to be spread out here. So I'm going to need to, each time through, update my vector 3. So what I'm going to say is I'm going to say curpos dot x is equal to curpos dot x plus 1.1. And that needs to be a float. So I'm updating the x coordinate on my vector 3 to be whatever it currently is plus 1.1 to keep bumping it over 1.1. Save this. And there is a whole bunch of guys there. Make sense? I could have done this a million times, right? And then a whole bunch of those guys would have popped up. Now, a little bit of computer science evidence that's happening here. I was able to start off with a default vector 3 and then nudge that vector 3 each time through, changing its value such that this guy was not changed. What kind of animal? Well, this guy right here from the previous one didn't update to the new one. That's kind of what I'm getting at here. So my very last vector 3, my very last box or cube I placed is going to be way down the line, right? I'm updating the same curpos each time. What has prevented my original one from having his curpos updated so that he slid down there as I kept changing the vector 3? Make sense? I'm changing this guy here. All of these dudes are built in terms of a vector 3. So one of two things is possible here. So these are the kinds of questions that a computer programmer should be asking themselves. Why didn't my last curpos affect my first curpos or my second curpos or my third curpos? Well, two things are possible. And one of them is what's going on here. One possibility is that when we first instantiate something, it uses this position as its starting point, but then it's going to build a brand new game object. And what's the most generic game object you could have? Something with just a transform. So it's going to have its own brand new, fresh transform component that happens to copy the values from curpos into his position aspect of the transform. Therefore, us going back and changing curpos later would not have an impact because those values have already been copied over. Okay, that's what's actually happening here in this case. But let's assume that that isn't what happened. Let's assume that what this guy actually did is he set his position equal to this guy, not copying the components over, but actually set it equal to that guy. At that point, changes to this vector 3 potentially could have changes to previous things we put into the scene. And this comes down to this idea of passed by value versus passed by address. Vector 3s are a struct type. Okay, so it's a variable type that's of type vector 3 that holds 3 floats, x, y, and z. Okay? Structs are passed by value. So right off the bat here, I am passing a copy of this particular vector 3. So any changes I make to that vector 3 out here would not have an impact to the dude that was passed in here anyway. That makes sense? As opposed to objects being passed by address, where if I make a change to the object out here, any objects that I've previously, any time I've previously passed this object around, if they're maintaining an instance of that object, my one change will have a permanent change on all the different guys. Make some sense? All right, so important thing to kind of keep tabs on here. The important lesson we want to get from this is just reminding us that vector 3s are structs. So whenever we pass vector 3s around, we're passing a copy. Make sense? Okay. That way we don't really need to worry about changing values on a vector 3 later on. So this allows us to more easily bump this guy around. Okay, so now the next thing we might want to do is we want to build that grid, right? Instead of just building this straight line, we want to build the grid where it was 3 rows by 3 columns. How are we going to accomplish that? How can I modify this code to give myself, instead of 10 things in a row here, I want 3, then 3, then 3. Go ahead.
You say like if I is equal to the 3, or like, and then like if I is equal to 6, like add 1 to the, what would it be, like the y, I guess, if you're paused. So then it would like, it will still like keep adding 1.1 to the f, or 1.1 to the x, and it'll create the next 2, and then once it's on like a, like once I is equal to like 3 or 6, it'll like drop down 1.
Okay, so you could ask questions about your I, right? So you could say something like, if I is equal to 3, bump it down by 1, or if I is equal to 6, bump it down by 1.1 on the y. All right, so so maybe inside of here, probably at the very beginning is where we want to do this. We can say if I is equal to 3 or I is equal to 6.
Just a better way would probably be like I divided by 3 is like has no remainder, but yeah.
Well, yeah, but if we do that, then we'll bump it down right off the bat.
Oh, true.
Yeah, so which might not be a big deal. We'll just be 1.1 down for our very first row. Not the end of the world. But we're only doing 2 rows or 3 total rows, so this isn't a huge deal. So in this case, we would say curpos dot y, and I'm going to just do the shorthand, plus equals 1.1f. So that'll kick it down a row. What should we expect from this?
Like that.
Yeah, it's going to look kind of cool, but it's going to be procedurally a little bit different, right? It does kind of look cool.
Oh.
And notice it's because we added 1.1, it goes in the other direction as opposed to minus 1.1. That just has to do with how the axes are represented. All right, so it still looks cool. We're procedurally generating a staircase is effectively what we're doing. Yeah. Okay. Not a big deal. Looks kind of sweet, but still a thing. Now, right off the bat, are we kind of seeing just the power of procedural generation? It's not going to solve all the world's problems, but there's some things that would just be tedious to do when you really need, let's just say staircase. Let's use a staircase as an example. You might have staircases throughout your game, and maybe you just decide, look, I want to generate a staircase at this position that has 10 steps or 15 steps. So you could just have a function that says generate staircase, pass it 15, and it will go and generate a 15-stair staircase. Make sense? Okay. And you can even then give it a parent transform. You can create an empty game object, give that guy a parent transform, and then when you want to reposition the staircase, you could just reposition the parent, and everything else will drag with it. Go ahead.
Doesn't this happen at runtime? So when you're like messing around with like your scene in Unity, it'll just be a blank space where stairs will be at runtime?
Yep. Okay. But one thing you could do is now you can combine some of the strategies we've learned already. So if you think back to our Golem game, remember we had our spawn points? Mm-hmm. So what you could do is you could just drop a little game object in your scene that, an empty game object, and, maybe color code it, put the little orange dot on it or something like that, and say the staircase is going to go here. Okay. And then you just attach the script to it for generate staircase. Let me kind of show you what that means. So I think that's kind of an interesting approach to this. So I'm going to come in here And we might need to pick this up next time, but I think this is a pretty, let's call this guy a, all right, we're going to call this guy a walkway. I'm going to go ahead and add a couple of cubes to it. And then we'll add another cube. All right, so we have a perfectly awesome walkway here. And then what I'm going to do is I'm going to go ahead, we're going to have a staircase come off the end of this guy. So I'm going to go ahead and create an empty game object here. And we're going to call this guy stairs. And we'll go ahead and flag this as, you know, maybe a little orange thing here. So I'll go ahead and drag my stairs over. So we're going to say we want some stairs at that position. So what we're going to do is we're going to create a little script. Create C# script. We'll call this guy gen stairs. All right. Now we could probably say we could say gen stairs in a certain direction if we wanted to, whether they're stairs going up or stairs going down, so we can manipulate it there. But what I'm going to do is I'm just going to start off with just number of stairs for the sake of time. All right, so here's our gen stairs. I'm going to go ahead and we're going to have two public fields here. One is going to be our kind of a step, a single step on our staircase. So I'll have a public game object, call this guy a step. And then we'll have a public int number of steps for the number of steps in our dude here. So I'll go back into Unity here, and I'm just going to quickly create a step. So we'll say a step is going to be kind of a flattened cube, maybe. So we'll give this guy a scale of 0.2. And 0.2. Look straight down on it. All right, and then maybe 0.5. That's a step. Call that guy a step. All right, so I'm going to go ahead and just name this guy a step. And we will drag him into our prefabs. All right, so what we'll do, I'll put the assignment up today for the next several assignments, but what we'll do when we come back on Thursday is now that we have a step, we'll go ahead and finish up our script where we're going to drag in a step for our primitive thing. We're going to say how many steps do we want to generate, and then we can just have little empty game objects like this, attach that script to it, say I want to generate 10 steps, and then at runtime, 10 steps will show up. That makes sense? Kind of giving us some real life examples of procedurally generated stuff. Go ahead.
Does that take a lot of processing power if you just kind of like get that right away?
A lot is going to be relative, depends how much you're doing, but keep in mind we're doing this on a wake. So if you've probably seen it in video games before where you start the game and it says loading. So there's all sorts of crap that happens before the thing actually pops up on the screen. So we can say it's not a big deal because it's not hurting the performance at runtime because these dudes are there. Once it's on the screen, it's as if you had drugged them there yourself. Okay, but it is something to be considerate of. If you're procedurally generating a billion things and your game takes 8 minutes to start, that might be problematic. Okay. Make sense? Questions, comments, concerns, bribes? Hey, remember today, student, faculty, staff Bible study, God in Grub. Tuesday, go to the cafeteria, sign in, get free lunch, take your tray down to the terrace room. I'll save a seat for you. Also, you're invited to chapel. I sit in the front row. Plenty of room up there, people. And I will see you when I see you.